I'm Jake O'Neill, creator of Animagraphs, and this is how a diesel-electric, heavy-haul freight locomotive works. Diesel-electric locomotives have remained popular for over 60 years. As a measurement of capacity, they can take a 2,000-pound chunk of freight nearly 500 miles on 1 gallon of fuel, which is 3 to 4 times more efficient than a semi-trailer truck. Let's start with the body and frame. Most modern freight locomotives are hood units with a slim middle section and walkways on the outside of the body, allowing visibility in both directions. The nose portion is full width or wide cab. Locomotives mostly run short hood first, as designated by the decal letter F for front. Metal body panels can be opened or removed for maintenance or emergency access. Main sections are the nose and operator's cab, auxiliary or aux cab, which is packed with electronic components, the engine, and radiator cab at the rear with various cooling components and the onboard air compressor. The body and critical components are supported by a thick steel or steel alloy platform called the underframe. A pilot or cowcatcher sits at the front to deflect obstacles that could derail or damage the locomotive. There's an overhang called the anti-climber that prevents deflected objects from flying into the cabin. Concealed collision posts on each side further protect the cab in the event of an accident. There's a unique ID number displayed on the front and sides. A set of air horns sits on top of the body, and there's an electronic speaker attached to the underframe to emit a bell sound. A large manual handbrake wheel is visible near the rear. Coupling. Locomotives can couple with other locomotives or train cars. There are various coupler types. Our locomotive has a more complex Type F coupler, versus the simpler Type E style on our train car. Type F, for example, has robust side features to prevent vertical movement in accident conditions, where Type E requires no such protections. Couplers are designed to work by bumping into one another. They'll couple in various arrangements, for example with both couplers open, or one closed and one open. As knuckles make contact, their rounded shape causes rotation that presses against the knuckle thrower. Which in turn moves the lock. The lock rides along an internal channel and also rests on a sloped feature at the back of the knuckle, so that it naturally slides into locking position as all parts reach the end of their travel. For uncoupling, there's a manually operated bar called the pin lifter or cut lever. When rotated, parts operate in a reverse sequence to coupling. The lock rides upwards, pressing the knuckle thrower, which rotates the knuckle into open position. The coupler is attached to the draft gear assembly, which provides a kind of suspension between train cars. During impact coupling, also known as a buff event, the coupler is forced backwards against the draft gear, which compresses an internal stack of rubbery discs. The draft gear's rearward travel is stopped by thick metal tabs at the back. When train cars pull away from each other, also called a draft event, the surrounding yoke pulls the draft gear against a block at the front, causing the internal discs to again compress and absorb potentially harmful forces. When cars are coupled together, a hose is also connected to supply air for individual car brakes, and a cable for cars equipped with electronic brake support devices. More about these systems later. When multiple locomotives are coupled, the MU, or multiple unit connector, brings mechanical, engine, and electrical systems under control of the lead locomotive. The connector sits in a dummy receptacle when not in use. 3 additional hoses synchronize braking operations between locomotives. There's the main reservoir hose, the actuating hose, and the brake cylinder hose.